Okay, hi guys. We're going to talk today about chemical reactions. We're going to go over a few things we talked about in class, and then we're going to introduce you to talking about counting atoms, okay, which is going to lead us into our next lesson next week for balancing equations and following the law of conservation of mass. Okay, so take some notes. There's not a lot to write down, but you'll need to write down especially every example I give you so you can work them out and use them as examples when you come to class to do your work on Monday. Alright, these are the main ideas that you're going to learn in this lesson and in the next lesson that I give you next week. You don't have to write this down. You will be writing other stuff down that is similar to this, so you don't need to write this down. Okay, so like we talked in class, some changes of how we know a change occurred, a chemical change or a chemical reaction has occurred. Okay, we have our color change. Okay, remember we talked about it could be physical or chemical. In order for it to be a chemical change, it has to completely change the substance and make a new substance. In some of our classes today, we talked about, we actually watched a video with that occurring. Okay, so that's our color change. We saw a video in class with some examples of some chemical changes that showed color. Okay, our next example, or excuse me, evidence of a chemical change is when we form a precipitate. Remember, this is when we made our copper out of our solution of copper chloride in water, and we poured it over foil. Okay, and we saw that we had copper left over from liquid. Okay, remember, a precipitate is any time that we have we form a solid from two liquids. Okay, all right. Our next change okay, we have the gas formation. Remember, we talked about bubbles. Now, just to clarify, sometimes bubbles do not mean a chemical reaction. For instance, if you boil water, you'll start to see bubbles. That does not mean that there's a chemical reaction taking place. Okay, in order for a chemical reaction to take place, something must be completely changed. Okay, all right. Odor, if you leave trash out for too long, you leave your lunch out and you don't put it in the refrigerator, you leave it in your locker for several days, it starts to smell because it's starting to break down. And we know there's bacteria and other things working on it that are creating these chemical reactions to break down that matter. Okay, two forms of evidence that have to do with energy. Our first one is changing temperature. Okay, we talked about these today, our endothermic, remember, and our exothermic. Our endothermic, we're going to feel cold because we're absorbing the heat, and our exothermic, we're going to feel hot because we're releasing the heat. All right, and then we also know when light is produced, that is also a sign of a chemical reaction. If we have a glow stick and we pop it to start the reaction, you will see light. If we see a lightning bug, we will see light. Some things will pop. Some liquids, when you pour them together, you will see a spark or a light come out of them, and you know that is a chemical reaction. Okay, all right, now we're going to focus on talking about elements and compounds. Okay, so we are going to break down what an element is and what a compound is. Okay, so an element is the purest form of a substance. So you need to write that down. An element is the purest form of a substance. Okay, examples of elements are hydrogen or iron or copper, like we used. Okay, anything that has a capital letter, okay, we know is a new element, and that will come in handy here in just a second. So this is one element. Because it only has one capital letter, we know that this smaller letter goes to it, and it's all one element, which is the element of iron. Okay, a compound is when we put two or more elements together. So write that down. A compound is when we put two or more elements together. So for instance, this is a compound because we have two oxygens. It's not just pure oxygen. It's O2, which is the oxygen that we breathe. So there's different types of oxygen. Okay, another example of a compound where we put two or more elements together, our water molecule, H2O. We have the element of hydrogen and we have the element of oxygen. Okay, and we actually have two hydrogens for every oxygen to make our compound of H2O. So I'm going to give you some examples here. Okay, and I want you to tell me if they are compounds or if they are just elements. Okay, so tell me, are these elements or compounds? H2O. It is a compound. Okay, we have hydrogen and oxygen. Fe. That is an element because it only has one capital letter. ClO2. This is a compound because we have chlorine and we have oxygen. CuO2. This is a compound because we have copper and we have oxygen, two capital letters. Okay, Ag. This is an element. We only have one capital letter. Okay. All right, now we're going to talk about atoms in a compound. So here is our compound. Okay, how do we know, what is this number right here? Why do we care about this number? This number is called a subscript. Okay, this subscript tells us how many atoms, so the number of atoms. That is not a hashtag, that is a number sign. So this tells us the number of atoms that are in that how many atoms of an element we're going to use to make the compound. Okay, so we see here there is no number. That means there's an understood 1. Okay, so this is saying that we are going to use 2 hydrogens and 1 oxygen for every water molecule that we want to make. Okay, so let's try some more examples. Okay, all right, remember, let's label this as our subscript. Subscript tells us how many atoms. Okay, so how many atoms of copper do we have? Correct, we just have 1 because there's an understood 1 there. How many of oxygen? 2, correct, because we have our subscript of 2. Okay, let's try one more. Okay, all right, so we have our element iron, our element carbon, and our element oxygen. Okay, how many irons? 1, correct, because we have understood 1. How many carbons? 1. How many oxygens? 1, because we have understood 1. Okay, are we still, am I not recording for real? I lost my example. Okay, all right, so now let's try, now what if I did this? Okay, now we added a new number in. So we have our subscript here. And now we're going to have what's called a coefficient. Okay, now our subscript tells us the number of atoms. Okay, our coefficient is going to tell us the number of molecules. Okay, so it's going to tell us how many of the whole thing are we going to have. Okay, so here is a great example I want you to write down before we go any further. Okay, here's how you remember what all these numbers tell us, the subscripts. Okay, so this is, we're going to have in a car, let's relate this to a car, you're going to have 4 tires. Okay, you could have 2 doors. And you're going to have 1 engine. Okay, so that's how we know what the subscript means. Okay, now if we do it again, okay, now what if we add the coefficient? Okay, now the coefficient's telling us how many of this whole thing. So we could write 2 of these just like this. Or we can make it easier and we take this coefficient and multiply it by every single subscript. So now we have 2 cars. Well, now we're going to have a total of 8 tires, a total of 4 doors, and a total of 2 engines. Okay, so the coefficient is what we multiply out to our subscripts. It's telling us how many. So we have 2 cars here instead of just 1 because our subscript told us that. So let's try some examples with our compounds. Okay, so let's go back to H2O. Okay, we have our subscript and our coefficient. Okay, so instead of writing it all out, we're just going to multiply. Multiply here. There's no number, so it's understood 1. We have our 2 elements, hydrogen and oxygen. So in total, we're going to have 4 hydrogens and 2 oxygens. So we'd have a total of 6 atoms. Okay? Alright, let's try it again. Okay, so let's try this one. Try to work it out first. Alright, so we have our 2 elements. We have iron and oxygen. So there's no number right here, so we have an understood 1. So we multiply 3 times 1, and that is equal to 3. And you multiply 3 times 4, and that is equal to 12. Okay, so we have a total of 15 atoms. Okay, one more example. Okay, we have our 2 elements. So we have no subscript here, so we multiply. That is a 2. We have no subscript here. That is a 2 also, so we have a total of 4. Okay, now what if I did this example? This will be our last example. Okay, so now we're going to do just like in math. So now we're saying this, we have to have 3 of these compounds to make 1 of these compounds. So what we would do here is multiply this subscript times this subscript to be 12. So that's actually just writing this again. So now we have our iron and our oxygen. So now we're going to multiply out. Now we have 9. Okay, and then we have our oxygen times 3. Okay, because we're multiplying out, that's 36. Okay? Alright, be prepared to do more examples of these in class, and then we'll have another assignment where we actually get into our equations.